Hello, folks. For next 30 minutes, we're going to delve into the networking portion of vSphere 7 with Kubernetes. So I'll be joined by my colleague, Jeff Wilmington. We'll tag team here. The first thing I want to do is take 10-15 minutes to set the context, and we'll walk through the demo. So we'll kick off from where Bo left off, right? So this is the VMware Cloud Foundation Services. What it does is it enables your traditional vSphere platform into a Kubernetes-driven platform. What that does is for two personas. One is IT admins or IT ops who are well-versed with operating the infrastructure using VMware's native stack, continue to use their IT tools to drive the infrastructure, whereas the folks who are developing the cloud native or modernizing their application can now drive and deploy their applications in a self-service model using vSphere 7 feature that we just launched, and Bo went into details on it. But for this segment, what we are trying to cover is the networking service. As you see, vSphere 7 with Kubernetes, VMware Cloud Foundation Service is made up of a lot of self-service entities. There is a virtual machine service, there is a Tanzu Kubernetes service, vSphere pod service. But for this discussion, I'm going to focus on network service and how NSX is driving all that self-service model for networking of these workloads when they're deployed. So at high level, if you look at it, we looked at how the architecture, platform architecture, we looked at how VCF enables IT admins to bring up their infrastructure and enable it as a workload platform, which in turn is supervisor cluster. But now I'm showing you a diagram of once you set up a supervisor cluster and deploy your applications, developers deploy their applications using their Kubernetes dial tone. From a networking perspective, how does the view look like, and what's the value NSX brings in behind the scenes as developers are deploying these workloads in a self-service fashion? The first and foremost, NSX provides an isolated topology for each supervisor cluster. As you enable supervisor cluster, behind the scenes, NSX being the integral part of the vSphere 7 with Kubernetes stack, now goes and maps out a typical isolated segment. As you see, it sets up a routing topology here with two-tier routing topology that NSX supports. So you have a tier 0 gateway that has a leg to outside physical world, which is given supervisor cluster, all the traffic would come in and go out through this tier 0 gateway. And then for every supervisor cluster, there is another routing boundary. And below the supervisor cluster, we have our data plane, which is a distributed virtual switch. That is where the endpoints or your workloads get connected. That's the data plane. And that's where a lot of services, networking services are realized on the vSphere host as you turn the vSphere cluster into a supervisor cluster. So at the bottom, you'll see pods. Bo touched upon it. You can run pods natively on ESXi or vSphere host when you turn it into a supervisor cluster. Now, those pods could make up a microservice, and when you publish those microservices within the namespace, you would use the Kubernetes constructs like cluster IP. So cluster IP is realized via distributed load balancing, NSX distributed load balancing. That's the new capability that we are bringing in to enable this capability for applications that are deployed within a namespace on a supervisor cluster be exposed to other microservices within the namespace. The next step is when this microservice needs to be exposed to outside world, outside of the supervisor cluster, that's when NSX's edge load balancer comes into play. And as the developer or DevOps persona is deploying an application with a service of type load balancer, behind the scenes, NSX is going and plumbing all the load balancing entities or objects on the NSX edge load balancer, creating VIPs, creating the members or the endpoints for this as you publish that application. And last, from a security perspective, if a DevOps persona wants to control who can have access to his or her microservice, they can go and create a network policy that Kubernetes exposes. Now, behind the scenes, again, NSX converts those network policies into firewall rules and applies it at the pod level. So that's the distributed firewalling. So net, these are the capabilities NSX provides at high level. Now, the 5 key things that NSX as a platform, networking and security platform, what it provides for vSphere with Kubernetes is, first is the IP address management, which is very critical. As we are deploying these endpoints or the applications, there should be an entity that is doling out IP addresses to each of these endpoints, and NSX provides that capability. Next is, as you're creating network namespaces, networks need to be isolated based on namespaces. You need to apply some kind of network boundaries to your Kubernetes applications, right? So behind the scenes, NSX is building those network topologies based on best practices. And the third is the critical aspect, which is from a security perspective, you want to isolate namespaces. As IT admins are creating namespaces to create these application boundaries, you want to isolate those boundaries through firewalling, and NSX provides it. Last but not the least is another important capability, which is how do you publish applications to outside world and provide availability and scalability of your applications dynamically. That's NSX's load balancing. And the last one is from an IT operations perspective, as DevOps are deploying these applications, myriad of applications, maybe a given application could consist of hundreds of microservices. How do you provide IT ops with tools to troubleshoot and have visibility in the infrastructure? So we have built some tools. We'll be demoing it shortly. My colleague Jeff will show what we have done so far for this capability to provide IT admins with an option to triage issues quickly. So we'll go through quickly all the 5 key things. First thing is, as Ranjit walked through some of these, in his demo, walked through the setup of a supervisor cluster. The first thing IT ops or IT admin does is, I want to enable this vSphere cluster, which is the lowest entity of workload platform, with Kubernetes APIs, which we refer to as supervisor cluster. IT admin has to provide a set of IP addresses so that when DevOps folks deploy these applications, IP addresses are coming off of these blocks. So the first things what IT admin does is gives NSX a set of IP CIDRs as pools, so that NSX behind the scenes as DevOps persona is deploying applications can pull an IP and apply it to the services or the endpoints. Okay, so the next capability is the firewall capability, right? So for every supervisor cluster, there would be an edge firewall that is hosted on tier 1. So as an IT or a security admin, he or she has the flexibility to go and create firewall rules to apply their best security best practices on which traffic can come into this supervisor cluster and which should not be entertained or allowed into this supervisor cluster. The next thing that NSX provides, especially from a Kubernetes construct, is by default, each namespaces, when an IT ops creates namespaces, these namespaces are isolated. That means behind the scenes, NSX creates a default deny posture between the namespaces. So namespaces cannot interact with each other. That's the default security posture. If 2 namespaces need to interact, then IT admin needs to go and plumb a network policy to allow inter-namespace communication. The next thing is, from a DevOps perspective, DevOps persona has the ability to allow or deny which entity can talk to the application via network policy in Kubernetes. Behind the scenes, NSX goes and realizes the Kubernetes network policy on supervisor cluster via the distributed firewalling service. The next key feature is load balancing. Again, once you deploy these 3 kinds of workloads, you want to expose those applications either within the namespace or to the outside the cluster. So this is where NSX load balancer comes in. So for what we refer to as east-west load balancing or cluster IP, That is where distributed firewalling is, distributed load balancing is realized. So as DevOps persona deploys a workload and defines a service of type cluster IP, NSX behind the scenes creates a distributed load balancing for that microservice. And anytime a DevOps persona creates a type load balancer or type ingress for that service that is deployed in supervisor cluster, that is realized as a layer 4 virtual server or a layer 7 virtual server in case of ingress on the edge load balancer that is associated with that namespace or that supervisor cluster. And then for the Tanzu Kubernetes clusters or guest clusters, as the DevOps persona deploys their own third kind of workload, as I mentioned, the Tanzu Kubernetes clusters, then DevOps persona wants to expose some of those applications to outside this guest cluster, outside this TKC cluster. And again, it's two-layered here, right? So the workload, as you see in this diagram, you have a guest cluster or a Tanzu cluster that needs to expose an application to outside world, outside meaning outside of supervisor cluster. That's when a cloud provider load balancing is leveraged, just like in any other cloud. So here, NSX providing the load balancing can act as the cloud provider, will act as the cloud provider load balancer, and that's integrated into vSphere 7. So as DevOps persona deploys a service of type load balancer in the Tanzu cluster, behind the scenes, a load balancer VIP is created on the supervisor cluster load balancer to expose that application to outside world. We'll walk through this in the demo. That will get clearer. Last but not the least, it's about visibility from an IT ops persona perspective. So from NSX UI or API, IT ops persona now can view the network topology and the inventory of all the Kubernetes endpoints that are being created on this supervisor cluster. And from a troubleshooting perspective, NSX provides a cool tool for IT ops persona. For example, from a connectivity perspective, as DevOps persona is deploying all these objects, services, firewall rules, if there is no connectivity between two endpoints, the first thing that happens is a call to their network admin folks. So the first thing network admin needs to have is a tool to figure out in which part or which layer the issue is. So NSX provides a nice tool. Now we have integrated with this Kubernetes feature as well. So here in this trace flow, you can trace a flow between point A to point B, and it shows all the layers. And if for some reason a DevOps persona defined a network policy that denied a rule and he expects the application to have connectivity, that's where the trace flow would detect, okay, a certain firewall rule is being hit, and that's the reason why it's being denied, so you can quickly triage the issue. So that's the high-level overview. Now I want to shift gears and go to the demo. My colleague Jeff will walk you through behind the scenes live, just so you get a good glimpse of what's happening behind the scenes as you set up and deploy the workflows from both IT admin persona and DevOps persona. Jeff, take it away.
David, hey, thanks. Hey, can you move the slide forward once? So I want to kind of set the stage a little bit for folks. What we're going to show here is a couple of different demo workflows. What the VI admin experience would look like, what the developer or the DevOps experience would look like, and then day two operations, kind of what Vinay talked about in terms of things like visibility and troubleshooting and being able to see kind of what's going on, if you will, behind the scenes as these workflows are going through. So I'm going to share my screen here real quick. So a couple of different, I want to kind of set the stage here. On the left, or on the screen left here, is the vSphere client. And on the right-hand side is just a terminal window. We're going to show some kubectl commands, etc., and how to move around through the interface. So as Ranjit and Bo went through and talked a little bit about namespaces, etc., and I know there's some questions around namespaces. What does that look like, etc. When you when we have this deployed, the concept of a namespace, once workload management is enabled, the cluster, this cluster here that's enabled for workload management, has the capability to create new namespaces. And within those namespaces, you can see I have several, I have a couple of different namespaces here from that perspective. And I've created a nice one here called TFD for Tech Field Day. And Ranjit's workflow showed how to create that namespace, how to assign it permissions, etc., and allow the developer access. So once the actual namespace is actually created, what we need to do is we're going to provide the developer access to the kubectl commands, right? So there's a specific version of kubectl that allows the access through like vSphere login for you to be able to access the kube API server. So I've got it installed over here. I'm not a cool developer because I'm running on Windows, but that's okay. This just goes to show that it doesn't necessarily matter. From there, you can run it on Windows or you can run it on Linux from there. So functionally, what I'm going to do here is I'm just going to log into my API server. This is logging into the supervisor cluster itself. I've actually typed in my password here. And you'll see that I have access to quite a few namespaces in here and quite a few contexts, just simply because I am the administrator and I'm just using a simple user ID and login right now. So for us to take a look at the TFD context, we would need to change our context over to the TFD. And from here, what we can do is we can actually see that we don't have any pods necessarily running in this namespace right now, but we're gonna change that up a little bit. We're actually gonna get some pods in here. So what I'm gonna do is I'm going to change over and change to my directory here. And inside my directory, I have a few. I have an ingress policy and a deployment that I'm going to run, and then we're going to go through NSX, and I want to show you the concepts that that Vinay showed and how NSX does all of this kind of behind the scenes. So we're going to do a, as opposed to hearing me banging on a keyboard, we're actually going to do a deployment, a simple deployment here. And from a vSphere admin perspective, you can see that I'm now spinning up a TFD Nginx container or a vSphere pod actually within this namespace. And this is running on one of the ESXi hypervisors. If I actually click on this and see a summary, you'll see that it's actually running the native vSphere pod, this Nginx instance, on my ESXi dev 01A host. If I were to, go ahead.
So Jeff, what you did is basically you are a DevOps persona now. You just logged into your namespace and you created an application and you deployed an application onto the supervisor namespace called TFD.
Absolutely. And so if we were to go back and take a look at the YAMLs that I created here, really what I did was I created a deployment, I created a service with a load balancer service, and you'll see that here in just a second. And then also I created an ingress policy for us to be able to control the inbound traffic and permit access to the actual workload itself. So all of that was done just by the normal commands that you would run just by running the YAML kubectl apply commands. And from this perspective, we would flip over to NSX, and we're going to kind of see what's going on a little bit behind the scenes here. So the what I really want folks to understand is that NSX is very behind the scenes here, right? There's nothing other than the configuration of actually standing up NSX that I had to do here to create any of this information. I'm going to flip back over to the command line for just a second because I want to show the service and you'll see that with my deployment, I've created not only the container, the pod, the vSphere pod, but I've also exposed it externally to an external IP of 192.168.0.66. And if I'm a DevOps persona, I could actually curl to the VM or to the pod, to the vSphere pod, and I can see that I'm getting a response from that. Now, from the NSX side of things, let's take a look at kind of what's going on a little bit behind the scenes here. So Vinay talked a little bit about how this topology actually looks. And so what we want to do is we want to talk a little bit about the tier 0 gateway. This is the tier 0 gateway that's going to be doing the connection outbound for the actual instances, right? So this is connected to my physical network. It is peered with my physical network and is providing the ingress and egress north-south access to the actual instance itself. From here, the tier 1 gateways that were created, there's one simple tier 1 gateway. Pay no attention to the red here. This is still a beta build, but the tier 1 gateway that's created for this, you can see that this is the tier 0 and this is the tier 1, and this is the kind of visibility, if you will, that doesn't exist, I think, with a lot of other products, right? With our ability to see that this is the tier 1 gateway that was provided for my supervisor cluster. I can see there's 3 VMs, which are my supervisor cluster control plane VMs, and I can see that there's 1 pod running there too. And that's the pod that was created, that I just created, the DevOps person created with the kubectl commands. So very, very nice granular visibility from that perspective. Let's take a look at the segments. Each namespace, we created a namespace for TFD, right? That namespace is now going to get its own segment that's attached to that tier 1 gateway. And when I do a filter here, you'll see that the segment is just a segment off the domain named TFD, specifically named after the namespace. It has an IP subnet that's allocated for it, and you can see that if you were to do from the DevOps persona perspective, if you were to do a kubectl get pods, you will see that the IP address that is assigned is within the same range. I have to do a Y for that. 10.22.244.0.226 is assigned automatically on this same subnet. And we can click over here and see that this is the segment port that was created and attached to the vSphere pod and attached to that segment. So now this is just again, very fine, very great visibility into how everything is actually plumbed together. We'll go down a step further and go to the load balancer. I have a few load balancers here set up. We're going to talk a little bit about the other load balancer, the small load balancer here in just a second. The distributed load balancer that Vinay referred to, that's for cluster IP. And then we have a server load balancer here as well. When we go into the actual virtual servers, remember we exposed this pod, this vSphere pod externally. We exposed it on 0.66. So if I do a search in here for IP address, 192.168.0.66, and I apply it, you can see that that I now can see the virtual server that I created just with that YAML file. The vSphere admin can now see that there was a load balancer type that was created and assigned for this for this specific vSphere pod. So that shows all of that networking functionality. But let's take it even a step further here, and let's go over to security. Remember, I created an ingress rule policy, right? I created a policy that specifically stated that I only want this container to talk to specific types of services. When we created that service, when we created that network policy, we got 2 distributed firewall rules here, one for isolation and one for whitelisting. And the ingress policy was translated by NSX into a distributed firewall policy and applied to the actual pod itself, meaning that we can actually create security policy. The DevOps persona can create security policy without having to know anything about NSX. They just create the security, they apply it as they normally would to their pod, and they inject it in and deploy it out. And this is all being translated on the back end. And again, we had to do nothing to make this all work. And that's a huge, huge benefit, I think, from that perspective. So I want to flip back over here and just show that within this namespace, we've created a nice vSphere pod. Does anyone have any questions up until now? Because we're going to take this even a step further, and I'm going to show you some other cool things. Okay, we're going to move forward. So Ranjit and Bo, and we all talked about, and Vinay, we all talked about how you can run native vSphere pods on the actual ESXi hosts within a namespace. But what if I'm a DevOps persona and I want to create another entirely different Kubernetes cluster that I want to run on that as well? So I can actually go through and create a Tanzu Kubernetes cluster running inside my namespace on those ESXi hosts, and I can run pods from there too. So as you see here, I've created a couple other different namespaces here. One guest cluster and guest cluster 2. You can see on this guest cluster, what I've already done is I've peeled this, right? I've actually prepared this one in advance, just so that we can, in the interest of time, since I don't have too much time to talk about this, we can do a proper demo. But this is actually a Tanzu Kubernetes cluster running in a namespace, running VMs as a namespace. So now I can actually, as a DevOps person, I can go through here and say, well, maybe I want to create a DevOps cluster. And so here's my YAML, right? As I use my YAML specs to build out my vSphere pods and so forth to run in the supervisor cluster, now I can run a managed cluster, a Tanzu Kubernetes cluster within that namespace as well and run pods inside that. And you can see this YAML spec here says I want to create one control plane node and a couple of workers. And I'm going to use this distribution, and we're going to apply it out to the actual system itself. And when you apply that via kubectl apply to the guest cluster namespace, I get this Kubernetes cluster inside of a namespace running on top of the supervisor cluster. So I know there was some questions before, and so I know we did some slides. I'm hoping this visualization helps you understand kind of the concept and understand the way that it looks and feels, if you will, for the vSphere, for the VI admin, because they still have to manage these things, right? So we still know we still know that these are being deployed here. So what I want to do now is I want to show if I decided to go ahead and deploy another cluster, all I would have to do is I've created the guest cluster 2 namespace. From here, as a DevOps administrator, I'm just going to go to log in to I'm going to log into my deployment, log into the API server. I'm going to change my context to the guest cluster, and I'm going to take a look at this and show you a little bit about what you would do. If I was going to deploy this guest cluster YAML out, I would deploy it out. And when I'm done from the command line, I can describe the cluster, and I can see that my nodes have been deployed. My guest control worker nodes have been deployed. They're ready. They're running. The node status is in ready, and there are no events that are showing that the cluster is down. From this perspective, all I have to do at that point is I just have to log into this guest cluster, right? Because this is I now have a new API entry point to that guest cluster. So what I need to do is I need to log in to my Tanzu Kubernetes Tanzu Kubernetes cluster. It's the guest cluster that I've named. I'm going to log into it the way I would normally log into it. And I have to type my password right. And from here, we're going to see that I'm going to change my context, guest cluster. And when I do a kubectl get pods, there's nothing there. That's cool. That's fine. But what we're going to do now is I'm actually going to create some pods there. So inside this guest cluster, I'm going to do a kubectl apply, and I'm gonna do my demo application. And folks are probably familiar with this. This is the Hipster Store. I think this is probably a great demonstration, just simply because it is a polyglot, application. It has several microservices running inside of it. So we're going to go through and do this deployment. Now that I've applied that YAML, the same way I deployed the YAML when I was in the supervisor cluster, and I do a get pods here. I'm going to watch my pods because it takes a little bit of time. Add service and cart service just need to start. They're taking a little bit of time, but they'll start here. So cart service started. I can now see when my pods are done. Just wait for the add service to start. And once the add service starts, we'll take a look here and we'll see what all kind of went on behind the scenes. So we're doing a little bit of dream within a dream, right? A little inception here, but we're running this application inside of a Kubernetes, inside of a Tanzu Kubernetes cluster that's running on a supervisor cluster on an ESXi host. So from here, our pods are done. They're all running. I'm going to get my services because my services, I exposed some services during that process. Again, if you saw from here, I created a front end service and I've exposed that service out as well. And when I've exposed that service out through the guest cluster, it's pulled another IP address from NSX on the load balancer. And I want to make sure that this application actually works. So I'm going to browse out to the Hipster Store, and I can see that the Hipster Store opens up just fine. And this is from the VI admin or from the end user perspective. I have started Hipster Store inside of a guest cluster, inside of a namespace running on ESXi, and to show the difference here, you can, if you did a get pods 0 or a -0 with a wide, you would see that it's a little tough in this resolution, but you can see that the pods are running on the actual worker nodes that were created as part of the process. So it's a little tough to see again, but you can see that it says guest here, guests, and guest cluster worker nodes. Those are the worker nodes that were created as part of the guest cluster deployment or the Tanzu Kubernetes cluster deployment. So I'm not running these on the supervisor, I'm running these on those actual worker nodes that I just created. So from there, let's go back to NSX. What I'm going to do now is go back here to the networking. As we create guest clusters, like Vinay said, we're going to create other tier 1 gateways for those different guest clusters. And so you see here, I have a new tier 1 gateway for the guest cluster that I created. And if I click on the topology, you can see here that I have the virtual machines, my worker nodes that are running there as well from that perspective. So that is the demonstration I wanted to show. Not only can I run vSphere pods on the supervisor cluster on the ESXi hosts, but I can also run a guest cluster running Kubernetes and run pods on those VMs, and still all behind the scenes, I never touched NSX. NSX is technically invisible here, right? It does all of the orchestration for the networking and security, and nobody had to go through and do any of that portion.
Okay, thanks, Jeff. Any questions before we move on to the next session? We are running a bit late, I guess. So,
just one quick one. I noticed we have the option for distribution. Can you give us a quick rundown on what our options are and how that will change over time?
Yeah, I think I will let the WC, like Bo and so forth, answer that question. The versions that we're currently running right now, yeah, we do have some distributions, but I want to let those folks talk about that because they're the ones technically controlling those distributions. But yeah, that makes sense. Definitely a good question.